Welcome to our Oilfield Water Services Field Case Study series. My name is Ross McCartney, and in this series I'll be showing you field examples of how produced water analyses can be used to benefit scale, water, well and reservoir management. For all these case studies, where they have been published, the reference for the work is given at the end of the presentation. In this presentation, you'll learn about how produced water analyses can be used to provide PLT-like zone information from commingled wells. The method was developed by Chomsland, myself and others for use on wells producing from two zones, with each producing water with a different composition. It involves undertaking a multi-rate production test on the well, during which produced water samples are collected at the wellhead or the test separator at each production rate. Water allocation for the two zones is obtained from interpretation of the produced water analyses, and these results are then integrated with well flow rate and pressure analysis. The result is that for each producing zone you can obtain oil and water rates, water cut, downhole pressure, productivity index, water allocation, produced water composition, injection water fraction, and you can also identify the nature of water being produced. The method was developed to test wells on the Veslefrikk field in the Norwegian North Sea. These wells produce from both the Brent Group and the Intra-Dunlin Sands, or the IDS. Produced water samples had been collected from all the wells over time before development of this method, so there was a good set of historical data available for use. For example, this figure shows produced water chloride and sulfate concentrations for one of the wells, well A4. This well produces from the Oseberg II formation of the Brent Group and the IDS. The green symbols are Brent Group formation water samples from the field, and the red symbols are those produced from the IDS of A4 prior to water production from the Oseberg II formation. You can see that the Brent Group samples are low in sulfate but have variable chloride concentrations, indicating that formation water compositions vary in the Brent Group. You can also see that the IDS produced water has less variable chloride content but elevated sulfate content. This is because in this well, injection water breakthrough has occurred in the IDS, and so the IDS produced water is a mixture of formation water and seawater. Now, at the time of multi-rate testing, both the IDS and the Oseberg II formation were producing water. During testing of this well, 3 samples were collected, one at each of the 3 different choke settings and flow rates. The compositions of these samples are the black symbols. These samples are mixtures of water produced from the IDS and the Oseberg II formation. From the data on this plot, the composition of water being produced during the test from each zone can be estimated, and the nature of the water being produced can also be identified. For the Oseberg II formation water is being produced, and for the IDS, a mixture of formation water and seawater is being produced. The fraction of seawater being produced can also be calculated. As the well was choked back, the sample composition moved toward the Oseberg II formation water composition, indicating that proportionately more flow was coming from the Oseberg II formation. In turn, this indicated that the higher pressure zone is the Oseberg II formation, whilst the IDS is the lower pressure zone. Water allocation to each zone at each rate can also be calculated from the produced water analyses for the test. When these water allocation results are included in the analysis of the multi-rate test, that is, via the use of hydraulic software, graphical analysis and Monte Carlo optimization calculations, oil and water rates, water cut, downhole pressure and productivity index for each zone can be calculated. This figure shows the results for well A4, confirming the higher pressure, higher productivity index and lower water cut of the Oseberg II formation in the well. For this well, it was found that both zones have a reduced productivity index, and this was probably due to calcium carbonate or barium sulfate scale deposition during production and crossflow between these zones. A PLT was run in this well after the multi-rate test, and this confirmed the key test results. As a result of all this work, the IDS in the well was sealed off and the well was reperforated higher up in the Oseberg II formation. This resulted in the oil rate increasing by approximately 150 standard cubic meters per day, whilst the water cut was reduced. A scale inhibitor squeeze was then performed to avoid further scale deposition, but it was not necessary to use flow diverters to improve inhibitor placement because the IDS had been isolated. Since development of this test method, it has been routinely used on this field, often as a direct replacement for more costly and riskier PLTs. The information gained is beneficial to those involved in scale management. For example, knowing the composition of water being produced from each zone and the rates allows scale risk predictions for each well to be improved. Also, for those wells where crossflow can occur, it has allowed the risk of formation damage via scale deposition to be predicted. And because these wells are squeezed to mitigate scale deposition and formation damage, knowing the near well scale risks and zone pressures has allowed the design of squeeze treatments to be optimized. The information from these multi-rate tests has also been used to verify the reservoir model. This has been achieved by comparing the results of each multi-rate test with model predictions and then using this comparison to modify the reservoir model where it is required. The information has also been used to aid planning of water shutoffs and well stimulations. And finally, when additional perforations, stimulations or zone isolations have been undertaken, multi-rate tests have been performed both before and after to allow the success of these operations to be assessed. I hope this brief presentation has given you a greater insight into the value of produced water analyses. If you require further information, please visit our website at www.oilfieldwaterservices.co.uk, where you will find our extensive publication list, which cover many field cases. You can also contact me via my email on ross@oilfieldwaterservices.co.uk. Don't forget to subscribe if you want to see more videos from us on the uses of produced water and formation water analyses in the oil industry. Thank you for your attention, and I hope that we can be of service to you soon.